Now in this question we have an equation that involves both r and theta. Now remember in previous two problems we had theta, like an equation that entirely dependent on theta and entirely dependent on r. In other words, we can say here theta does not change and r did, and here r did not change but theta was the changing term. But if we have an equation like this, both theta and r will change, or in other words, we have to look for the proper relationship between theta and r. So one way to do this is, now suppose if we are back into the Cartesian coordinate system, right? And if we have an equation like this, let's say y equals x squared, then a very elementary method of obtaining the curve of this equation is to plot x and y, right? Say for example 0 0 is 1, 1 is 1, x equals 2 is y equals 4, x equals 3 is y equals 9. Likewise, we find the values of y manually and plot them in the plane, xy plane, and obtain the curve, right? So we can do a similar process here by finding out the suitable r for different values of theta. So here if we do that and if we find several values, we can see starting at this point you will obtain a curve of this nature. It's also a circle. Now see, for example, at theta equals 0. Now remember, we are plotting this one in the polar coordinate system, not in the Cartesian system, right? So at 0, at theta equals 0, that means this one. Now this is the representation of theta, right? So if it is 0, then that means there is no angle, then r value should be equal to 2. So at theta equals 0, r value will be 2. And let's have theta equals pi by 2, then the r value will be 0. So when theta equals pi by 2, r value will be 0. So it will eventually give the this pole, right? Remember, for the pole you can represent it with any angle value as long as you have 0 in the radius, in this place for the radius, right? And similarly, for plotting for different values like this, you can see, you can observe that the curve will take this shape. But it's of course not an easy task to plot, to obtain values of r like this, and it is not easy to guess the pattern of the curve, right? So therefore, for that reason, we have adopted a different method to plot curves like this, right? Now for these two cases, of course, by thinking about the r and theta values, we can easily plot the suitable curve, because here there's only one variable that change out of theta and r. But since this one varies for both theta and r values, it's not easy to determine the correct values, right? So now, for example, even for a case like this, 1 plus sine theta, r equals 1 plus sine theta, it is not easy to plot or to find the corresponding r values for different thetas, and it is not easy to plot the suitable curve. So we have adopted a new technique that involves the Cartesian system as well, and I will explain it in the next video.